Hey guys, Peter here from Sigma. I just wanted to quickly talk about how to install your motion system onto your rig. This applies to any motion system. In this case, we have the DK6 on the Spec 282 chassis, Tilt B10 bucket seat with our electric slider, wheelbase, and pedals. And this is kind of the typical setup you'd have. Most chassis that you get about just over 4 feet in length. This one roughly is about 4 feet, a few inches, about 130 plus centimeters. And with most setups, the company will ask you to put the driver on the back, obviously put the pedals right here, something like that. Maybe have the uprights here a bit more forward. But the three things we're going to address when installing a motion system are safety, load, and balance. So safety being number one, what we want to avoid is a tip over hazard. So now that we're lifting the chassis off the floor and we're trying to achieve an optimal mounting location for the actuators, what some people quickly realize is that if you put the actuators closer together, you get more of a mechanical pitch and roll. So if, for example, these actuators right now are about 39.5 inches or so center to center, but our minimal install distance is 20 inches, which is about here. So if you put that front actuator all the way here instead of here, you'd get a lot of mechanical pitch. And you're like, oh, that's great. I want more pitch. I want more roll. I want to use more of the 6-inch travel that these actuators have. So that sounds like a great idea. But now what happens is this becomes a pivot of the rig. So if you have a heavy wheel base, which most people do, you have heavy pedals, you have a lot of stuff in the front, and let's say you're a light driver, you jump on the rig, and yes, you have more mechanical pitch, but now if this wasn't here, but this was here, you have the chance of this actually lifting the rear actuators, pitching forward and hitting your monitor, or getting something like actuator slap in the front, where during motion, the actuator in the back will start coming off the ground and slapping into the ground, which is what you don't want to have with any motion system. So typical setup, again, given that most chassis are 4 feet because of the shipping constraints, it's just cheaper to ship a 4-foot piece like this than it is a 6-foot or 8-foot for the oversized handling charges that you'd get in North America. We typically would see a setup like this. And so put the front actuator usually in front of the uprights. You could probably put it up here as well, depending on your setup, but the rear actuator is always in the back. Now, in terms of the load, we do want to make sure that the 4 actuators are working as equally as possible. That's usually, again, very hard because of the length of the extrusion. And if you have a tall driver, a heavy driver, like let's say you have a 250-pound driver in the back here, you could see that the rear actuators are doing most of the heavy lifting. The front would not. So in that case, what again we recommend is to spread out the load. And these are all kind of tied in together. So the safety, the loading, and the balance are all tied in together. But have the driver as close to in the middle, let's say like this, as possible, so that the 4 actuators are sharing the load. If you have a longer chassis, like some of our commercial chassis, which are 5.5, 6 feet, like this, 5 feet, you'd have the actuator here. So we wouldn't have to move the seat as far forward in order to make sure that the majority of the mass or the payload is in the middle between the 4 actuators. So in this case, we probably, if this was like a 250-pound driver, we went from the rear actuators doing about 60, 70, maybe even 80% of the load, again, depending on the rig, to now probably doing about 60% or so, and the front one's doing about 40%. Now you can move these actuators forward here as well in order to have them carry more weight of the driver, like if you have an exceptionally heavy driver and you have a light front end. But typically this is what we'd recommend, again, to prevent that tipping over hazard, which would be our first consideration. In some rigs where you get a really heavy front end, we'd actually recommend moving the actuators forward. And again, it's so that the rear actuators pick up some of the load that the front actuators are holding on to. So again, safety, load, and then the last one is balance. Balance Again, they're all correlated, but balance is more in terms of the feel of the motion system. So in this case, this is pretty much what we do. We'd put the driver, especially in our Tillet B10 bucket seat, which has a very low hip point. Yeah, actually it's just lower than the frame here. And we use very short uprights and electric seat rails to keep everything nice and tight and constrained, so there's very, very little movement here. But if we were to draw a line like this across the actuator, you can see that a kind of rotational center would be probably about somewhere right here. And we want to bring the hip point of the driver as close to that as possible. And then the next consideration is to put them as low as possible for that roll center as well. Same thing, if you're in a race car or a sports car or any kind of performance car, you want to be close to the center of the car. Keep the weight as close to the center of the car as possible. But being close to the center, you also get a very quick response of the pinch and the roll. So you can imagine if you're at the end of the seesaw, yeah, you get a lot of motion, but it's a bit slower to have the change of direction. Whereas if you're closer, you have less motion, but a faster change of direction. So again, keep the driver nice and centered, keep them nice and low. I would probably lower this even more. In some of our other setups, we have the seat rail basically right here, right in the middle of the extrusion. And also these actuators have multiple mounting positions. In this case, we have the DK brackets all the way down, and we have the brackets installed on the actuators all the way down, so as low as they can go. And then the brackets are all the way up on the extrusion, so we have about 2.5 inches, about 60, almost 77 centimeters off the ground here in its powered off state. So that's about it. That's kind of what we'd recommend. Just to quickly recap, most likely when you get your system, push this actuator all the way back, put this one in front of the uprights. Now depending on your weight, your length, your setup, we'd recommend bring that seat as forward as you can, that it's comfortable. That means adjusting the wheel a little bit back, a little bit forward as well, and then overhanging the pedals as much as you can so you can accommodate the driver being in the middle between the four actuators. Any questions or comments, do let us know. Email us, call us, or leave a comment down below.